Welcome back to 6-Minute Math, where we turn confusion into clarity 6 minutes at a time. Thank you for joining us today for our first of 4 videos discussing exponent laws. 6 minutes goes by quickly, so here we go. Our key points for discussing today's exponent laws are to understand that both the product law and the quotient law require our powers to have the same base. That will be very important. When I am multiplying powers with the same base, I'm going to add the exponents together. If I have an example here of a to the power of m times a to the power of n, my base is a, and I can add those exponents together. Conversely, using the quotient law, if I am dividing powers with the same base, I will subtract the exponents. A to the power of m divided by a to the power of n. My base is a, and I will subtract those exponents. So let's see some examples. We're going to simplify and then evaluate 3 squared times 3 to the power of 4. I have my exponent law here, and I know that I have the same base of 3, so that will be the base of my simplification, and then I add my exponent laws together. 2 plus 4 is equal to 6. I would then evaluate this, and 3 to the power of 6 is 729. How about if I were to simplify 4 to the power of 7 times 4 to the power of negative 3? I have a common base of 4, and then I will add my exponents together. 7 plus negative 3 is going to equal 4, making my simplification 4 to the power of 4. Evaluating 4 to the power of 4, I would get 256. How about if I were to use my product law using variables? Let's simplify x to the power of 5 times x cubed. I have a common base of x, so I would add my exponents together. 5 plus 3 is 8. Y to the negative 4 times y to the 6. I have a common base of y, and then I would add my exponents together. Negative 4 plus 6 is going to equal 2. Y squared would be my simplification. Let's look at some quotient law examples. We're going to simplify again and evaluate 6 to the power of 5 divided by 6 cubed. I have my quotient law that states if I have powers with the same base, which I do of 6, I can subtract my exponents. My base stays the same, and 5 minus 3 is equal to 2. Evaluating 6 squared, I would get 36. What about 5 to the power of 7 divided by 5 to the power of 4? I have a common base of 5, and 7 minus 4 is equal to 3. 5 cubed is going to be equal to 125. On to our last couple examples. We're going to simplify x to the power of 5 divided by x to the power of negative 3. I have a common base of x, but using my quotient law, I need to subtract my exponents. 5 minus negative 3. When I subtract a negative, it is the same as adding, which would make my answer 8, giving my simplification x to the power of 8. For my last example, I'm actually going to use both of my exponent laws. You can see here I have a common base of y, which would make my final power have a base of y. And then I would use both my exponent laws to simplify. I'm multiplying powers on the top, so I will add those exponents together. 6 plus 3 is 9. And then I'm dividing, so I take that 9, subtract 5 for y to the power of 4. Those are all the examples we have today for product and quotient law. If you didn't see the exponent law you were looking for, be sure to check out our other videos on the channel. Follow us on Instagram and TikTok at 6 Minute Math, and be sure to like, share, subscribe, and leave a comment below for any topic you want to see me tackle in a future 6-minute episode. Always remember that the best way to get math is to practice math, so keep on practicing. And until next time, keep solving and evolving.